Hello everyone, today let's take a look at QP16, the very first question on the Quantipus roadmap. Now this is a classic question taken straight from the Green Book. A lot of these questions will be from the Green Book as that is basically the best resource out there. However, I'm going to along the way try to fix a few of the problems that the Green Book has. Number one, not very good solutions or very dense solutions, so I'm going to try to make some better solutions to these questions. Number two is some of the ordering issues that the Green Book has. For instance, when you open the Green Book, the very first question that you see is the Pirates one and not the Tigers and Sheep one, right? This one comes after in the Green Book for whatever reason. If you do this question, QP16, and the Pirates question, which will be QP10, you'll pretty clearly see that this one is just a simpler version of that one. So that's essentially what Quantipus is all about. I want to structure these questions better. I want to provide better video solutions and have basically a website instead of a book, right? Because we are in the 21st century. So anyways, back to the question. QP16, we have 100 tigers and 1 sheep placed on a barren island. If a tiger eats the sheep, then it's going to transform into a sheep itself. All tigers are perfectly rational, named the 1 stay alive and 2 eat the sheep if it's safe to do so. So given these conditions, will the sheep be eaten? So the first part of this roadmap is the most important part, right? It's going to be about simplification and recursion, which you can use in every single problem. It's just basically if you have a hard problem, just simplify that problem and then build your way up to the higher cases. Like for instance, in this example, we have 100 tigers and 1 sheep. Do we want to deal with 100 tigers straight away? Well, no, we do not. Instead of 100 tigers, we can start with 1 tiger and see what happens in that situation, right? And that's going to be a lot simpler to think about than just starting straight away with 100 tigers. So that's the number one most important strategy for any of these questions. It's simplifying the initial problem if it's hard, right? So the simplest possible case in this problem is when I have 1 tiger and 1 sheep on my island. So what's going to happen in this scenario? This right here is supposed to be a tiger and this is supposed to be a sheep. I didn't draw them very well, but that's what they're supposed to be. Now it tells us that every single tiger is perfectly rational and these are their priorities, right? Number 1, they want to stay alive, and 2, they want to eat the sheep if they know that when they eat that sheep, they're going to stay alive themselves, right? So in this case, what's going to happen if the tiger eats the sheep? Well, we know that when a tiger eats a sheep, it transforms into a sheep itself. So let's say the tiger eats this sheep right here, right? Now it's going to become a sheep, and now there's just going to be 1 sheep left on this island. And now if there's only 1 sheep on the island, right, there's going to be no tigers left to eat it. So this sheep is going to stay alive indefinitely. So the tiger understands that, so it's going to be incentivized to eat that sheep right there, right? If I can get my tiger back. So when we have 1 tiger and 1 sheep, the answer to this question, will the sheep be eaten, is yes, because the tiger knows, again, that when it eats the sheep, it'll transform into a sheep itself, and then it can't be eaten because there'll be no tigers left on the island to eat it. Now let's move on to the situation where we have 2 tigers and 1 sheep. So now what's going to happen if one of these tigers decides to eat the sheep right here? Let's figure it out. So let's say this tiger right here decides to eat this sheep. Well, then it's going to transform into a sheep, right? And now there's going to be 1 sheep and 1 tiger on this island, right? This was previously the other tiger. And now after that happens, we find ourselves back in the same situation that we talked about earlier. And we found from in that situation that the tiger is going to want to eat the sheep, because when the tiger eats the sheep in this situation, right, it's going to be left on an island by itself in which it will not be eaten. So therefore, since both of these tigers are rational, right, they both understand that if they eat this sheep, then they're going to wind up as the sheep themselves in the previous situation. And in that situation, they got eaten, right? So both of these tigers are not going to want to eat the sheep because they want to stay alive. Now you might be able to see the pattern, but if we have 3 tigers now and 1 sheep, like we do in this drawing over here. Now in this scenario, if any tiger eats the sheep, they're perfectly rational again. So they're going to realize that once they eat the sheep, they're going to transform into a sheep itself. And then they're going to wind up being this sheep in the situation when there are 2 other tigers on the island. And we found in this scenario right here that both of these tigers don't want to end up eating the sheep because they both know that they will get eaten themselves, right? So it's safe for a tiger to eat the sheep in this situation because they know that they won't get eaten after they eat that sheep. So for this situation right here, one of the tigers will end up eating the sheep because it will be safe for them once they transform into a sheep themselves. And now you can really see the pattern emerging, right? If I have 4 tigers and 1 sheep, none of the tigers are going to want to eat the sheep because they know that they will get eaten once they've transformed into the sheep in this scenario, right? So for 4 tigers and 1 sheep, the sheep won't be eaten. For 5 tigers and 1 sheep, the sheep will be eaten. And then we have this alternating pattern. So what's the pattern? If we have an odd number of tigers, we basically have a yes, right? We have the sheep will be eaten. And if we have an even number of tigers, then the sheep will not be eaten. So here's our pattern, right? Odd number of tigers and 1 sheep implies that the sheep will be eaten, and an even number of tigers and 1 sheep implies the sheep will not be eaten. So in our case, we have 100 tigers and 1 sheep, right? That's what we were originally trying to solve, and 100 is an even number. So what does that mean? That means the sheep will not be eaten in that scenario. So the final answer to this question is no, because 100 is an even number. When we have 100 tigers and 1 sheep on this island, all the tigers are perfectly rational, and they understand that once they eat the sheep in that scenario, right, they will not be eaten by the other tigers once they transform into the sheep themselves.